Greetings everybody. So I just made a video to introduce what's happening in this problem, which I've taken from my math lab. And now I want to try to solve it the way that it's given. Okay. So quick summary, I'm given this differential equation in this proposed solution. Okay. And I'd like to verify that this solution is correct, or at least begin to verify it. All right. So I'll show you these first few parts of the question right here. Now, I'll summarize it like this. Okay, so I've got this differential equation, m, which is a constant, mass of a falling body, times the derivative of v with respect to t. Okay, that's the derivative of some function, v is a function of t, which was given, I'll show you in a minute, is m times g, those are both constants, minus k, which is also a constant, times v squared, which is this function squared. Okay, so that's how I would understand the differential equation. There's some function of t, which is a solution of this. This function works if you plug it in. Apparently, we're going to prove that. And I've got these other things identified as constants. So I have that. That's the scenario in the problem. Here's the differential equation. Here are the parameters of it. And I want to check that this is the solution. Here's that function of t that is apparently the solution. It says v is root mg over k, that's a constant, times hyperbolic tangent of t, that's our variable, times root gk over m, that's a constant. Okay? All right, so here's what I have, and I want to check that this is the solution. So here's the way that I would go about this. If I wanted to check that this function made this equation true, I would probably work one side at a time. So in other words, I'll check just the left-hand side. The left-hand side is m times the derivative of that function. M times dv over dt. M times the derivative of this. Okay? So let's work that out. So first, what's dv over dt? What's the derivative of this function right here? Well, we'd have to know the rule to find the derivative of hyperbolic tangent in general. Okay? So if I have the derivative with respect to x, like say if x is the variable, hyperbolic tangent of u, where u is some more complicated function that involves x, or in this case, some other variable t, it's hyperbolic secant squared u times the derivative of the u. So in this case, let's see, I get to carry that root mg over k into my answer because it's a constant coefficient. The derivative of hyperbolic tangent is hyperbolic secant squared of t root gk over m. And then this part needs to be whatever the derivative of t times root gk over m is. But root gk over m is just a constant. And so that it's just the coefficient of t. So that's your du over dt. All right, so there's your derivative for the left-hand side. What if I multiply that? Or let's do this. Let's simplify this a little bit first. I can multiply this times this. See, root mg over k? I can multiply that by this other constant, root gk over m. Like this. Get one big root. These are both roots. I can multiply the insides together under one common root. I get the m's and the k's cancel. I get root g squared, and that's just g. Okay? So the left-hand side, which is m times the derivative up here, is m times g hyperbolic secant squared t times root gk over m. So that's how the left-hand side reduces. Okay? Now, if I am going to show that this function is a solution to that, I need to show that the right-hand side gets me the same thing. Okay? So now, let's look at the right-hand side. Oh, and in my math lab, our first objective is to figure out the left-hand side and say what it reduces to. There it is, okay? All right, now it's the right-hand side. So let's check the right-hand side. Here is the right-hand side of that original differential equation. mg minus kv squared, okay? So let's do this. I mean, m and g are just constants. We're just going to multiply them. Minus k is a constant, and I'm going to multiply by v squared. So the only thing I think that is of any difficulty in the right-hand side is figuring out what v squared is. So if v, that function that was proposed to be a solution from the very beginning, if that is root mg over k hyperbolic tangent t root gk over m, to square that, squaring this whole thing, would square this coefficient, mg over k, and square the hyperbolic tangent squared. That's what would happen. If you were to raise the product of two numbers to a power, each number gets that power. So that's what you're looking at. All right. So now that I figured out that, let's work the rest of this out. The right-hand side is mg minus kv squared. That's mg minus k times this. The k's cancel, and I get this. All right. So that is the right-hand side. Okay? All right. Now, let's put it all together. We'll get almost all the way there this time. So far, I've at least shown you how to answer the first few parts on my math lab. But it says, all right, is the left-hand side and how it reduces equal to the right-hand side? That would be mg hyperbolic secant squared t root gk over m equals mg minus mg hyperbolic tangent squared t root gk over m. That's what it becomes. All right. Now, is this true? If this original function is a solution to this differential equation, then when I worked out each side, then when I worked out each side of that, I should get agreement. All right, I should get the same thing. And these do look different, but there are lots of identities for hyperbolic functions. And we can use one in particular to show that this is in fact equal to that. Okay, so I'll leave it at that at this point, and I'll just say, but is this true? As it is, this is what I've reduced each side to. That's all correct. The only next thing to do is to show that this is true, that these are in fact the same. Now, I'll make another video. I'll make an additional part to this to show you how we do that. But at this point, I don't want you to get too lost on that. I want you to be able to take that original differential equation, work out the left-hand side correctly and the right-hand side, and at least get to here. In the next video, we'll talk about how you show that they are in fact the same.